Hello and welcome to video 5 for Math 123. This is our video that we're going to be talking about graphing. So when we're graphing, we're going to be using what's known as a Cartesian coordinate system. That is your X and Y axis, as you guys have probably encountered at some point in the past here. So the horizontal line, that is our x-axis. And it's basically the number line. 0 where these guys cross, 1, 2, 3, etc. goes on forever. And then -1, -2, -3. Again, similar to the very first thing we talked about in video 1, our number line. The y-axis is similar, we just rotate it 90 degrees. So the y-axis is the vertical. And as we go up, the numbers are positive. As we go down, the numbers are negative. We can see this is divided into 4 sections. We call these quadrants. And in this upper right section, this is quadrant 1. And as we move counterclockwise, they just go up. So quadrant 2, quadrant 3, quadrant 4. In quadrant 1, so let's assume that we lived here at the origin. Where these two cross, this is called the origin. And let's say we wanted to go to a grocery store over here. It is in quadrant 1. We'd have to do what? We'd have to go 3 units to the right, 2 units up. So right and up is positive, positive. So any point here in quadrant 1 is going to have a positive number and a positive number. This is what's called an ordered pair. With our x value coming first, the y value coming second. So again, if I wanted to get to this point, that's where the store was at, it would be 3 units to the right, 2 units up. So it lines up with these guys here. And this point then would be written as 3, 2. 3 units to the right, 2 units up. In quadrant 2, I have to come to the left first, so that means my first number is going to be negative, and then I come up into quadrant 2, so the second number is positive. So any number in quadrant 2 is going to have this property, negative number, positive number. Quadrant 3, we go left and down, so that's going to be a negative number and a negative number. In quadrant 4, we go positive. We have to go to the right first, so positive, and then down to get into quadrant 4. So that's going to be negative. So if you're ever in quadrant 4 and you have a negative number and a negative number, you know something is off. So that's why knowing these what's positive, what's negative can help keep that straight for you. Alright, so let's plot some points here. Let me make this a little bit bigger. Go to -4, +4. +4, -4 down here. Alright. And the origin, I should have told you guys this as well, this has coordinates 0, 0. So if we don't move off of there, we go 0 units left and right, 0 units up and down. So let's plot the following points. The first one is 1, 2. So they're both positive, so positive, positive means I should be in quadrant 1. X comes first, so 1 unit to the right, 2 units up. So that is that point right there, 1, 2. How about if I plot -3, -2? Well, that's negative, negative, so I should end up in quadrant 3. So -3, that's my x value, so -3 units over and then 2 units down, so that puts me right here, -3, -2. And again, we know that quadrant 3 has negative, negative as their values, so my point should end up in quadrant 3. How about if we have to plot the point 0, 1? So, again, first value in this ordered pair is my x is 0, meaning I'm not moving left or right at all. But I'm moving 1 unit up. So, from the origin, I move nothing left or right. I move 1 unit up. So this point right here on the y-axis would be 0, 1. And the fourth point we're going to graph is -4, 0. So that means what? From the origin, we always start at the origin, -4, so 4 units to the left, 0 units up or down. So I stay right on the x-axis. So that's my point there, -4, 0. Alright, so that is your coordinate plane. That is how the values set up on there, and then how we plot points. So, sometimes we can be given an equation with an x and a y and asked to draw a line. So, in the last example we just did, we were just plotting points. It just was one specific point, -4, 0, or 1, 2. But if I'm given the following, y is equal to 2x, and I'm told, okay, graph this line. So, we technically have an infinite number of answers for this, right? If x is 0, y is a certain value. If x is 1, y is a certain value. If x is -10, y is a certain value. So what we can do for this is build ourselves a table. And so the way this is set up, y is equal to 2 times x. So we're saying that, remember this is the section on functions. So y is a function of x. Depending on what we choose for x, leads us to a value for y. So just pick some random points. Let's do -2, -1, 0, 1, 2. So if x is -2, plug that in here, y is equal to 2 times x, which is -2. 2 times -2 is -4. Plug in -1. 2 times -1 is -2. Plug in 0. 2 times 0 is 0. Plug in +1. 2 times 1 is 2. And plug in 2. 2 times 2 is +4. So now let's go ahead and graph this. So this point here, we created an ordered pair, right? X is -2, y is -4. So -2, -4 puts me down here in quadrant 3. Remember, negative is quadrant 3. The second one, -1, -2. So 1 unit to the left, 2 units down. The third point, 0, 0, that's our origin. Fourth point, +1, +2. So 1 unit to the right, 2 units up. And the fifth point we chose is +2, +4. So that puts us up here. So you can already kind of see these dots are forming a line, right? Well, again, these are just the points we picked. I could have picked -½ and gotten a number. I could have picked 4 and gotten some number. So technically, even though these are the only points we picked, if we connect all of these dots, this line that we get, we're going to put arrows on both ends, meaning it goes on forever. Every single point along this line that we drew is a valid solution for the equation that we started with. So y equals 2x, if we graph it, looks like this line running on the slope there. Alright, so now, this that we just graphed, it what? It drew a line, and therefore it's known as a linear equation. And a linear equation, which means that the exponent on x is equal to 1. So if I have y equals any combination of x and numbers, as long as it's just x to the first power, is a linear equation. It is always going to give us a straight line. The features of these straight lines. So in that last picture, the line was running uphill. It has a slope, right? Think of like a hill, a real steep hill. So lines are always going to have slope, and we use the letter M to denote slope. Don't ask me why. And this is just the change in our y value over the change in our x value. And the equation for this then is y2 minus y1 over x2 minus x1. So in that last example, if we took one of the points, say -2, -4, and took another point, say 0, 0, and we plugged in the y value, and we plugged in the second y value, and we plugged in the x value and the other x value, when we simplify this fraction, that gives us what the slope would be equal to. We have what's known as intercepts. So the X intercept, and these are a little bit counterintuitive. So the X intercept is where the line crosses the x-axis, and this occurs when y is equal to 0. Right? So if we have our x-axis, that means we don't move up or down y at all. It's just on the x-axis. So that's why these are a little bit confusing. If you have to find the x-intercept, you set y equal to 0. If you want to find the y-intercept, then you do the opposite. Set x equal to 0. So the y-intercept is where the line crosses the y-axis. And we find this by setting, so I should put here, set y equal to 0, set x equal to 0. So as soon as we do that, that gives us our x and y intercepts. Now, to keep everything kind of the same across math, we have what's called the slope-intercept form. So if we're given the equation of the line, we can start to tell some information about it just because of how it's written. In slope-intercept form is y equals mx plus b. Well, this m, we just saw it, right? This is our slope. So if we think back to that equation that we graphed, we had what? Y is equal to 2x. So let's call it 2x plus 0. So it looks similar to this. The slope is the number that's in front of x. So in this case, instead of having to do all the calculations, all we have to do is look at, okay, what number's in front of x? 2. Well, then the slope of that line is 2, meaning that every time I move 1 unit over, I move 2 units up. Move 1 unit over, move 2 units up. That's why we got that steep line. And this b, plus or minus, whatever it is the y-intercept. So from this example, our y-intercept is what? 0. And remember, the line was going through the origin, so that makes sense that the y-intercept would be 0. Sometimes you will be given a point and you will be given what the slope of the line is, and you'll be asked to find, okay, what's the equation of the line, given just those two pieces of information. Well, when we have the point and a slope, we have what's called the point-slope formula. So you probably want this on your little quick reference note sheet, cheat sheet, whatever you want to call it. So we have y minus y1, the y value from the point we're given, is equal to m, our slope, times x minus x1, the x value from the point we're given. So we're given the point, we're given the slope, we plug those in, simplify it, write it in slope-intercept form, that would give us the equation of the line. A couple other features here. So we have parallel lines. So let's think about it. If I have a graph and I have two lines, let's pretend those are parallel. If those are parallel lines, what do we know about them? Well, first, they never intersect, right? They're always the same distance apart, like railroad tracks. But what else? Well, the slope has to be the same. The only way these guys never intersect is if the slope is the same. So for example, if I have y equals negative 3x plus 4 and y equals negative 3x minus 2, I know these are parallel lines without even drawing them, right? Because the slope of this line is negative 3. The slope of this line is negative 3, meaning they're running downhill. It's just where do they cross the y-axis? That's the only thing that's different. But because their slope is the same, then looks like my battery's going on. I better hurry. All right. So perpendicular lines. So perpendicular lines are lines that meet at a 90-degree angle. And here, the slopes are what we call negative reciprocals. So all that means is, whatever the slope is, take the negative of it and flip it. So for example, if I have a line that has a slope 3/2, and perpendicular we use like an upside down T. That's the shorthand for perpendicular. So if I have the slope of a line that's 3/2, the slope of the perpendicular line is flip these two numbers. So instead of 3/2, it's 2/3. And this was positive, so make it negative. And similarly, if this was given negative 2/3, negative, make it positive, and flip 2/3 to 3/2. And the last thing I'll try to fit in here before my battery dies on me, sorry about that, is vertical and horizontal lines. Vertical line has the equation x is equal to a. So if I'm at my graph, a vertical line is just whatever this point here where it's going through the x-axis, that's the equation. X is always equal to a. And our slope for this is undefined. So a vertical line has a slope undefined. Horizontal line this is y is equal to b, whatever the intercept is, right? So that still stays the same. And my slope here is 0. So if you encounter these sort of funny looking equations, x equals 3 just means it's a vertical line going through 3. Y equals negative 2, it's a horizontal line going through negative 2. And slope for vertical line, undefined. Slope for horizontal line, 0. It Remember what slope is, change in y over change in x. Y never changes, so the numerator is 0, therefore the slope is 0. Alright, so come on back and we will look at solving linear equations in our next video, but this wraps up the video on graphing and lines.